meeting is being publicly streamed.
Yes, sir.
Okay. Here we go. Basically, once we talk about the waves and superposition, okay, your main area, you told me waves and superposition. Okay, so here in the waves and superposition, I would like to give you a sort of detailed discussion, but you know, for informations, formula sheets, and definitions, we have to make a short summary of that. Okay, for that short summary, I would like to add some points here, and those points are basically very simple. The first thing you come across, that is the concept of your phase difference. Okay, actually I'm not discussing about v is equals to f lambda, so should I discuss that?
These, like the
Phase
formula.
difference. So phase difference, yeah, phase difference is represented by this phi, and its unit is basically either degree or you can say radian. But what will be its formula? That its formula is phase difference is equals to x divided by lambda into 360 degree, or the phase difference is equals to t divided by capital T into 360 degree. The same goes with the values of um, pi. So x divided by lambda into 2 pi. So here you will write radians with that, and if you
X of
write
what?
t divided by t into 2 pi radian, right? So here I will tell you that what is x, what is lambda, and all that stuff. So once I go to this x, so x is basically that small t, lambda, and capital T. These are four variables, and you must know about these four variables. That is why we are having a problem that what type of deviation or what type of errors we have. X is basically the distance between 2 points, two subject points. Okay, distance between two subject points. You know what are the subject points where you are going to find the phase difference? Okay, T is the time difference between two subject points. Difference between two subject points, where lambda is wavelength of the waves, either one or two, wavelength of waves, wave or waves, because they are monochromatic, so both the waves would be having the same wavelength, and this is actually the time period of wave or waves. Okay, is it clear to you? Any confusion in this one?
Yes.
Do you have any question related to that? Suppose you have a wave. Actually, I was not going to give an example right here,
For t,
but
you
because
will take time period of both waves. Sir. hear you. Sir. Sir, you are muted.
Yeah, yeah.
Yes, sir.
Hello, do you hear me?
Yeah, you were muted for a while.
Okay. Actually, that was the power supply gone.
Oh,
So let
okay.
me share screen again. Okay. Now do you hear me?
Yes.
Okay. So I was basically saying that once you have um, this formula, I was not supposed to draw the diagram and then explain to you, but as you were asking me a question, as I realized that yes, you would have some problems in that type of questions. That is why I would like to explain you with the topic. I think you have the issues in this, in that phase difference topic. Is it? Do you have some?
Yeah, if you.
Okay. So here we go. For example, if I say that yes, this is basically the wave, and that wave we the for the wave we have uh, this is a wave something. Oh my god, that is not a good software. It means this is a wave. Okay, this is your wave one, and then let's say I have another wave, and that wave is starting from here. It would join over here, and then it would be completed right at this point. Okay,
Okay.
this is another wave. So in these two waves, mostly the phase difference problem is typical when you have two waves. So in this situation, if you want to find the phase difference, what would be the phase difference of these two waves? Because this wave is starting from here. Yani, if I just consider that okay, it is it's some part of this wave is here. So I will just consider that what points do we have, and those points would be just considered exactly here. And for example, this is one point, and this is another point, right? Suppose it is 2, 4, 6, 8, 10, 12, 14, and then 16. Then what will I do? I will just consider the time difference or distance between these two waves, because this can be time in seconds, and this can also be your distance in centimeter or whatever. Because once this axis will give you the length, wavelength, and once it can give you a sort of time period. Okay, what is the wavelength or time period of this wave? X is the distance between these 2 points. So for example, it is at 2, and it is at yeah, it is, let's say, 2.5. This one is 2.5. And what about that one? Let's say this is at 7. So 7 minus 2.5, That is the x. And what about wavelength? What is wavelength of that? Its wavelength is, either you consider the wavelength of blue wave or that cyan wave, that both are having the same wavelength, so it is 12 centimeter. So if I apply that formula, that the phase difference is x upon lambda into 360 degrees, what will I get? 7.5 minus 2.5, 7.0 minus 2.5. What's the answer?
Yeah.
4.5
Yeah.
divided by 12 times 360. Yes, can you please calculate that?
Yes. 135.
135? Yes.
135. Yeah.
Okay, 135. So these waves have the phase difference of 135 degrees. Is it clear?
Yeah. Will there be a question where they have like different wavelengths?
No. For different wavelengths, we will not take the case because we consider the waves which are monochromatic. Okay. So what is the monochromatic wave, by the way?
Single wavelength.
Yes. Monochromatic waves are those waves which have single wavelength. They have a single wavelength.
Wait, it applies to all waves, right? All waves, right? Not just like electromagnetic.
No, 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 all the times.
Because
All the times.
yeah, name is a little confusing because like single color.
Yes, actually chromes is color, and once we talk about the color, we consider that this color pattern is from the light, and in the light this game is coming from that. In the light we have several colors, V, I, B, G, Y, O, R. That is why they all are of the different colors, and once we say this as a different color, we simply say that yes, Vibgyor is applied on all type of colors like electromagnetic and yes, all electromagnetic rays. Okay, is it clear?
Yes.
Okay, the next part of the game is basically your another very important question, and that question is, which is asked to you, that is the intensity of the wave. Okay, these are the two major questions which are asked in theory from this unit number 1, and one more is the Doppler's effect. So what is intensity of the wave? Yes, intensity is basically, if I write the formula, is energy per unit time transferred per unit area. So overall, it becomes power per unit area. That is why its unit is watt per square meter. Is it? What is its unit? Its unit is watt per square meter. So once you have this unit, it's quite simple to understand that watt per square meter is, somehow we can say that it is power delivered per unit area. So you can simply write that power transferred by a wave, transferred by a wave per unit area placed perpendicular to it. Placed perpendicular to it. Is it clear to you? Now the intensity has different domains in your uh, topic. That intensity is directly proportional to square of frequency. intensity is directly proportional to square of amplitude. Okay, so mostly what do we have? We have this question as a common question, that frequency of two waves is kept as constant, right? Mostly for, when we say the monochromatic, frequency of two waves is same. It means only the game is the game of area. And the game of area is there, sorry, amplitude is there. I would just give you a simple mechanism, that intensity of wave 1 divided by intensity of wave 2, that is equal to amplitude of wave 1 divided by amplitude of wave 2 whole square. Okay, this one. So
Yes.
actually, this is either asked to you as a separate question, this one. Okay, either it is asked as a separate question, or it is supported by, or it is equipped with the phase difference, right? This is a combination. For example, you have a wave and it is asked, okay, wave 1 has some intensity. Wave 1 has some intensity. For example, देखिए students, proper check कर students. Okay, this is your wave, and it's, let's say it is wave P, and its intensity is I. Okay, its intensity is I. Now, do you see the amplitude of this wave? It is 2 centimeter. Now I have another wave. You are asked to draw a wave. Sketch a wave. Sketch a wave R with intensity 3I intensity 3I, and phase difference is equals to, let's say, 90 degree or 270 degrees. So what would be your steps, or what would be your choice to solve this question? You have to solve this question in two ways. The first thing, that is, my first requirement is amplitude 2 is not known to me. Second thing, what I have to do, that the phase difference is given, but the position is not known to me, right? Phase difference is given to me, but position is not known. Starting position, you can say, position of wave 2. So I will work on these two. I will calculate these two, and then I will draw it. So first of all, I will make some calculations, right? What type of calculations will I do, right? The calculations are, simple. Those are, those calculations are, the intensity 2 divided by intensity 1 is equals to, what I told you, that intensity 2 divided by intensity 1 is equals to amplitude 2 divided by amplitude 1 whole square. Is it right? You got the point? Just a second, sorry. This way. Okay, so this is I2 divided by I1 is equals to A2 divided by A1 whole square, right? Now you will say that the intensity of wave 2 is given to this. All is your sketching. So I have to make amplitude 2 as a subject. Amplitude 2 divided by amplitude 1 whole square is equals to intensity 2 divided by intensity 1, and then I would take square root on both sides. Once I will take square root on both sides, that will make this calculation easy. That is amplitude 2 divided by amplitude 1 is equals to I2 divided by I1 square root. Now I will calculate the amplitude 2. Amplitude 2 divided by amplitude of wave 1 is equals to, what is the intensity of wave 2? That is 3. So it is 3I, and intensity of wave 1 is I, and its square root. So it would be gone. So amplitude 2 upon amplitude 1, that is equal to 3 square root. Are you getting my point? Square root of 3. So right after that, amplitude 2 is equals to square root of 3 times amplitude 1. This was amplitude 1. And amplitude 1 was how many squares? Yeah, this question is coming from this point. This is your amplitude 1, and that is equals to 2 centimeters. Now I will calculate what will be amplitude 2. That will be square root of 3 times 2. So that equals to what? How much value? You got it? Yes, Mohsen, welcome. Sorry, I did not realize that you are in the class. Yes,
She said 3.464.
3.4 centimeter. Right. So this is for your 2 marks. You did it. Now you will calculate the phase difference is equals to x divided by lambda into 360. So from here, your x is either you know the phase difference technically, or you can show that, okay, at which point I have to start this wave. So x is equals to phase difference times lambda upon 360. So I can simply make this calculation. What is the phase difference? Phase difference is 90 degree into what is the lambda of this wave, because they are monochromatic waves. So I can consider the lambda is, let's say, 2 squares, 4 squares, okay, and that is 8 squares. So 4 square is the lambda. So let's put the value 4 here and divided by 360. So what would be that? 90s 4 and 1. So it means that both the waves are aparted 1 centimeter from each other, right? Both the waves are aparted how much? 1 centimeter from each other. So your choice is either wave R is once is is starting 1 centimeter left or right, it does not matter, but it would remain at the same throughout. So I'm going to draw that 1 centimeter is this 1 square. So if I say that this wave has been started right from here, so this will be the behavior of this wave, right? But there is one problem, and that problem is that I did not consider the amplitude. What is the amplitude of the wave? 3.4. So it is 3 and 3.4. So it means that I have to draw that it is 3 and 3.4, almost this point. So I would just draw a dotted line here at 3.4, and again 1 2 1 2 3 and 3.4 position here, okay, and I will maintain the phase difference, and that phase difference will be something like this. Okay ji. Now what is the phase difference? I have to start wave from here. I will put it sorry, I will just make this wave maximum over here, minimum over here, then again maximum at this position, minimum at this position, maximum at this position above this, right? Minimum at this position, then maximum below this, then 0, and then maximum over here. So once I'm gonna draw this, I'm trying to draw this wave. This way. So this is the wave which you will have according to these terms and conditions. So these type of questions are asked to you from the phase difference. Is this clear to everyone? Yes. Hello.
Yes. Clear.
So is that phase difference problem to somehow clear to you or not?
Yeah, now it's clear.
Yes. So if you have any question in future, you can ask me right here that yes, I have a problem, so we can discuss that.
Okay. Can you send
Okay.
this all in the group chat?
Yeah, I will try to send it to you. Share this file, all 18 pages, PDF. Okay.
Yeah.
I will send you some other notes as well. I will try my best to make a summary of the notes and that because we have last